Hello friends, now we are on the 7th lecture. In this half an hour, we will discuss on various aspects of post harvest operations. We will discuss on primary process operations, secondary and tertiary operations, and toward the end of the lecture, we will also discuss details of pre-cooling technology, because the pre-cooling is one of the very important operation as far as the primary processing of the farm produce is concerned. Okay. So, earlier also we discussed that fruits and vegetables are important constituents of our diet, and they serve as a vehicle for nutrients like vitamins, minerals, sugars and fibers, but because of their growth nature, particularly vegetables, because of their proximity to soil when they are produced, there are various dirt, soil, there are bacterial contamination, extraneous matters etc. might be present in the commodity, in the fresh produce, and these make the commodity unfit for direct consumption immediately after harvesting. So, there are various processing interventions necessary to make the fruit or vegetable free from these contaminants, as well as to make it safe for consumption. So, what are the benefits of the processing, maybe primary or tertiary or secondary processing? That obviously it makes the material contamination free, it adds value in the produce, and more importantly, it increases the shelf life of the commodity. So, the processing operations include primary operations, secondary operations and tertiary operations. So, let us see what are these things. So, like primary processing. Okay. As I told you that in order to preserve the fruit or vegetable, or in order to convert them into value added product, they are many a times exposed to various conditions and methods like low temperature, thermal treatment, concentration, freezing, irradiation etc. So, these are done in order to preserve or add value into the commodity, but prior to subjecting the produce to these treatments, they undergo some operations, which is preliminary operation, or which we popularly call as primary operations. So, what are the major primary operations for fruits and vegetables? Like sorting and grading, washing, ripening, blanching and size reduction. So, in fact, some of these operations which are important operations we will take up separately also, and where we will study in the details of the methodology and what are the equipments etc. But today in this lecture we will have an overview, and I will give you the concept of all these things. So, let us see sorting and grading. Sorting and grading are the terms which are frequently used interchangeably in the food processing industry, but strictly speaking both are distinctly different operations. Sorting is a separation based on an individual physical property of the raw produce, such as weight, size, shape, density, photometric property etc. So, these are the various physical properties, individual properties of the material which are used to sort them and to make them of various groups. Okay. Grading is the classification on the basis of quality, incorporating commercial value and use and official standards. So, like grade 1, grade 2, grade 3, best quality grade. So, normally the overview that the sorting, the fruit should be ripe, but firm and evenly mature. So, all ripe fruits etc. they are kept in one group. Okay. Vegetables for sorting, it is considered that it should be tender and it should be reasonably free from soil, dirt, etc. But the grading is generally done after sorting. Here selection is based on the uniform quality like size, grading on the basis of size, grading on the basis of the color, okay, grading on the basis of the marketability, market appeal. So, it is done manually or with the help of various machines. Okay, there are various machines also which make them of different grades. Okay. So, these systems and all those things we will take up separately. Washing is another, as I told you, that the material, because of their produce from the field, when it comes, it may have certain dust, dirt, etc. So, the graded fruits and vegetables are generally washed with water in different ways like soaking and subsequent washing in running water, or spraying with water, or even spraying with dry air to remove any adhering material, unwanted material which is adhering on the surface of the produce. So, a thorough wash is very essential for improving microbiological quality of the product. As I told you earlier also, that particularly in the vegetables, because of their closeness, proximity to the soil during the production, sometimes the roots or tubers or bulbs, etc., which are grown inside the soil, are also there because of their nature. They are storehouse of various microorganisms, they can grow. So, in fact, while they are these for the vegetables, along with the washing, that is the washing solution should be even cleaning detergent, some sanitizing agent also is used in the like potassium permanganate, etc. Vegetables are soaked in a dilute solution, maybe 0.1% of potassium permanganate or sodium hypochlorite solution to disinfect them. That is very important in addition to washing, removing dirt, soil, etc. Agitation of the washing water is affected by means of compressed air or by means of a forced pump or even propeller type equipment. Among all, spray washing has been found to be the most efficient method for washing of the fruits and vegetables. Then ripening, we have discussed more about ripening in the earlier classes. It is the ripening, particularly in some cases in certain fruits such as avocado, banana, kiwi fruit, even mango, nectarine, papaya, peach, pear, plum, etc. before they are further processed, like before you put the mango for extraction of juice, for preparation of intermediate moisture food or for other product, okay, they need to be properly ripened. So, many a times that is the even artificial ripening under controlled environment, etc. These fruits are allowed to properly ripen. So, that is again considered in some cases in these fruits as a primary process operations. So, ethylene treatment can be used to obtain faster and more uniform ripening. So, the optimum temperature range for ripening in majority of the fruits is around 15 to 25 degrees Celsius, and within this range the higher the temperature, faster will be ripening. Also, by having a proper controlling the environment, etc., or by using the ethylene that is the promoters, that is more and more ethylene releasers, etc., some that ripening can be either enhanced or even by putting the ethylene scavengers inside the packet in modified atmosphere packaging, etc., even the ripening can be delayed. So, relative humidity should be maintained between approximately 90 to 95% during ripening. About 10 ppm of ethylene in enclosed chamber is sufficient to initiate ripening. So, in fact, banana, etc., the controlled ripening chambers are very popular, becoming very popular nowadays. Okay. Then blanching, again very important operation, pre-process operations. Okay, in many of the fruits and vegetable, pea, before they are canning, before they are drying, okay, before they are freezing or frozen storage, they are given some a heat treatment or some other treatment, mild heat treatment. It is given to the fresh produce such as like vegetables and etc. to inactivate. This is done basically to inactivate the enzymes like polyphenol oxidases, pectin methylesterases, polygalacturonases, etc. Because these enzymes, if they are not controlled, they may bring about certain changes in the produce during their subsequent operations like drying, canning, freezing, etc. Like the potato during the when you are making the potato chips. So, when you peel the surface of the potato, then these PPA polyphenol oxidase enzyme, they act on the substrate. These compound, these materials, fruits or vegetables, they have the enzymes polyphenol oxidase and the substrates polyphenolases, and which act on these, and the series of reactions takes place, and they produce that various brown color, dark color compound, which we call normally the this enzymatic browning. So, this needs to be controlled. So, even during the peeling operations, during the cutting operations of such vegetables, etc., that is the enzyme inactivation. There are methods for the enzyme inactivations, etc., which can be done. So, that is the blanching. Even you cut the apple, you peel banana, you see that their surface becomes dark. So, these are the cases of the enzymatic browning. So, the blanching is the operation to control these enzyme. Blanching is done by placing the produce in boiling water or steam for short periods, followed by cooling. In small scale industries, the fruit or vegetable to be blanched is placed in a wire mesh of the perforated basket, which is first dipped in hot water around 80 to 85 degrees Celsius for about 2 to 5 minutes, because these enzymes, that is the most resistant enzyme, heat resistance, that is PPO, etc., they can be inactivated under these conditions. Even microwave treatment is also used for blanching. Blanching requirement varies, however, with the fruit or vegetable, and it depends upon the relative enzyme concentration, maturity of the commodity, enzyme activity, presence of the type of the enzyme present in the commodity, and so on other factors. Okay. Size reduction again is an important operations. It involves peeling, coring, and sizing, slicing, etc. Okay. Peeling is done to remove unwanted or inedible material like peels, etc., to improve the appearance of the final product using a peeler. Coring is done to remove central inedible portion using a corer, like in some cases the pineapple, etc., there may be some blemishes or spots in the fruits, etc. So, using a coring machine corer, these are removed. Okay. There are commonly used peeling methods are include flash peeling for root crops, knife peeling for citrus fruits, abrasion peeling for potatoes, casting peeling for guava, orange segments, etc., or flame peeling for onion and garlic, etc. So, in the figure we have shown this some pictures of the peelers or corers, etc., but we will take up separately again. This is an important operation. So, size is a peeling, coring, slicing, etc., we will take up separately also in detail. Then let me now give you the brief of about secondary processing operation or actual processing, which we call, that is secondary processing of fruits and vegetables involves their preservation and the product development. They are exposed to, as I told you earlier, they are exposed to various treatment to either increase their shelf life or to add value, convert them into various value added product. Okay. So, preservation of fruits and vegetable can be done by various methods, like by drying, where the main principle is removal of water and reduction of water activity. Canning is done by placing the commodity in a container, packing the commodity in a container, then heating to kill the spoilage microorganisms. Pickling is done by controlling the pH, by reducing the pH, all right, and exclusion of the air by addition of vinegar, salt, oil, etc. Okay, it improves the taste as well as increases the shelf life. Fermentation is another method of preservation of fruits and vegetables, like your grape juice is converted into wine or such other beverage. So, it involves the fermentation process. It involves converting the sugars, carbohydrates into alcohol or organic acid. Freezing is another important method, common method used for extending the shelf life or preserving fruits and vegetables. In this process, there is a free water present in the commodity is converted into ice by lowering the temperature below its freezing point. Then salting, that is, it is done to arrest microbial growth by lowering the water activity or raising the osmolality of the produce. So, these are the various methods of preserving the commodity fruits and vegetable, and we will take up these separately when we discuss the concept or methods and principles of fruits and vegetable preservation. The other the process, the value addition or product development. In this, the fruits and vegetables can be converted into various value added products through various methods, which again we will take up separately. The products can range from the shelf stable products like chips, juices, concentrates, there are intermediate products like jam, jelly, etc., or high moisture fruit products. So, the fruits and vegetables, they are converted using different methods. They are converted into either powders or concentrates or juices, jams, beverages appropriately processed and packaged suitably, and here the marketability or the value is added into the produce, both from the quality point of view or economic value. Okay. So, this again. Now, in the tertiary processing, it includes that the packaging, both primary and secondary packaging of the produce, both raw, which may be whole or cut fruits or vegetable, or even the processed products. So, the tertiary processing, that is for the raw or whole material, that is a packaging, it may be the flexible plastic films, trays with over wrap or plastic punnets, plastic net bags or foam sleeves, etc., are used for packing the raw product, whole product. Cut fruits and vegetables, that is minimally, which is also called minimally processed fruits and vegetable, modified atmosphere packaging or active packaging, etc., is done. Okay. Of course, these again we will devote in the last at least one full week on the packaging requirement, packaging materials, etc., of the processed products. Okay. Also, we will take up separately the packaging related components of the fresh produce. So, in the processed product, PET, glass, cartons, etc., are used as a packaging material. Okay. Then now let us important primary process operation is pre-cooling. It is a very important operation, both from extending the shelf life of the produce for its processability and quality control, etc. Okay. So, pre-cooling plays an important role in, I told you, in prolonging the life of fruits and vegetable. What it does? It removes the heat, respiratory heat, field heat, as well as by reducing the metabolic activity. By reducing the field heat or respiratory heat, it ultimately reduces the metabolic activity in the commodity, and therefore, it is produced, it is sent or delivered to the processing plant or in the market in a good state. So, that is the pre-cooling. It is the first step of good temperature management of fruits and vegetables after harvest. And time and temperature management are the two most important features of pre-cooling. The speed of cooling, obviously very important, that is the even accessibility of the produce to the refrigerating medium, difference between the temperature of the produce and the refrigerating medium, velocity of the refrigerating medium, at what rate it is cooled, even type of the cooling medium, all these things are very important. That is a slow cooling, quick cooling, fast cooling, of course, different materials, different commodities, depending upon their respiratory behaviors, other constituents, etc. There are various methods, or one or the other method may be suitable for their pre-cooling. Okay. So, I will again emphasize that the proper pre-cooling is very important step. It preserves the product quality by inhibiting the growth of decay producing microorganism, by restricting enzymatic and respiratory activity, inhibiting water loss and reducing ethylene production. Okay. And it has a very important influence on the quality, particularly the lag time. You must ensure that it should have a minimum, as far as possible, minimum lag time between harvest and the cooling, because this cooling rate influences the pre-cooling, that it influences at the respiration rate. So, it is properly, if it is cooled and without any lag, the rate of the respiration will be reduced. It has influence on the metabolic activities, or there are effect of rapid cooling on ethylene production, then accordingly ripening, etc. And even very important from the market point of view, you can see that is even effect of delay before cooling on the quality of the quality of the strawberries. And if it is told that if at 30 degrees Celsius, if the pre-cooling is delayed by 8 hours, its quality marketability is reduced by almost half. So, that is from that point of view, for the raw produce, its marketability also is significantly influenced by the cooling and rate of the cooling, how cooling is performed. So, the pre-cooling temperature, now the important thing, that is what up to what temperature the material commodity should be cooled. So, generally the horticulture produces are cooled to their preferred or recommended storage temperatures. Before they are put into the storage environment, they are pre-cooled. Suppose, for example, recommended storage temperature for grape is 1 to 4 degrees Celsius. Though say they should be pre-cooled to 1 to 4 degrees Celsius, and then they should be put into the storage environment. Potatoes are normally pre-cooled to 5 to 9 degrees Celsius temperature. Banana, mango, tomato, etc. are cooled to 10 degrees Celsius temperature. So, all fruits and vegetables are mostly cooled by room cooling and are mechanical refrigeration, etc. Methods of, there are various methods of the cooling, we will take up in the next slides. Okay. So, according to the Indian Board of Horticulture or Indian Horticulture Board, fruits and vegetables such as oranges, grapes, tomatoes, beans, brinjal, okra, spinach, etc., that is which are highly respiring vegetables, they should be pre-cooled as rapidly as possible. Okay. Then the commonly used methods for pre-cooling of fruits and vegetables include room cooling, forced air cooling, ice cooling, hydro cooling, vacuum cooling, cryogenic cooling and evaporative cooling. Room cooling, that is pre-cooling of the produce in a cold storage room or in a pre-cooling room. It is an age-old or well-established practice. So, what is done, as you can see here in this figure, the produce is placed in boxes, bulk containers or various other packages into a cold room, where they are exposed to cold air. That is, there are cold fans or coolers, etc., are put into the installed into the room, and the cold air is supplied on the commodity. So, the working principle, how it works, that is, cold air is discharged into the room near the ceiling. It sweeps past the produce containers to return to the heat exchangers, and the cooled air is generally supplied by forced or indirect draft coolers. So, the commodity get cooled, and whatever that is the hot air is let to the out of the room by heat exchangers. Okay. Forced air cooling, it is used for rapid removal of heat immediately after harvest. This technique involves definite stacking pattern and the baffling of stacks, so that the cooling air is forced through rather than around. It is forced through the individual containers. The key to the forced air cooling is moving the cold air through the container and its content. That is, it is force, the air is forced through, that is the forced air cooling you see. So, the important factors in container ventilation and location of the container vents, stacking of the containers, size of the vents etc. This will influence the efficiency of forced air cooling. Produce can be cooled by a variety of different forced air coolants, like these includes air circulated at high velocity in refrigerated rooms by forcing air through the wires in bulk products as it moves through a cooling funnel, or continuous conveyors etc. by encouraging forced air through the packaged produce by the pressure differential techniques. Okay. You see here there is a forced air, forced horizontal airflow or forced vertical airflow. Okay. Vertical airflow, that is in a horizontal flow system, the air is forced, as you can see here in the figure, that is it is forced to flow horizontally from one side of the pellet load to the other side through the holes on the side. You see here there are holes in the side. Okay, other sides are sealed, tops and other sides are sealed. So, the air is forced here and it goes inside the material. In a vertical flow system, that is the you see the sides are sealed, that is the air is forced either from the bottom and it goes up from to the top. Okay. So, air is forced flow vertically from the bottom to the top the pellet through holes in the bottom pellet, and it container if used then out to the top. In this system, sides must be sealed to prevent the air from bypassing the produce. Then hydrocooling, produce is cooled by cold water either by immersion or showering water. Heat transfer takes place by conduction and convection. Heat transfer is faster than air cooling in this method, but it is more expensive method than the room cooling. Produce does not dehydrate, but get clean by reducing the primary inoculum load. Stems, leafy vegetables, some fruits and fruit type vegetables can be cooled by this method. Okay. Here you can see that there are two figures, that is cut away side view of a continuous shower type hydrocooler, that is the shower cooler. It distributes water using a perforated metal pan that is flooded with cold water from the refrigeration evaporator. It can be built with a moving conveyor for continuous flow operation, or they can be operated in a batch mode. Immersion coolers, you can see here the material is moving on the conveyor belt and then it is immersed in the cooling water. Okay. They usually cool slower than the shower coolers because water flows at a slower rate past the product. These are some of the photographs of conveyor based hydrocooling or typical batch hydrocooling. Then ice cooling. In this method, the crust or fine granular ice is used to cool the produce. The ice is either packed around the produce in cartons or sack as is shown here in the figure, okay, or it is made into a slurry with water and injected into boxes or waxed cartons packed with the produce. The ice then fills the voids around the produce and the heat transfer takes place, material get cooled. Then vacuum cooling is very important method, very commonly used method. Okay. Rapid cooling of horticultural produce can be carried out with the vacuum cooling. Vacuum cooling is achieved by the evaporation of moisture from the produce. The evaporation is encouraged and made more efficient by reducing the pressure to the point where boiling of water takes place at low temperature. So, what is the principle of vacuum cooling? That is at atmospheric pressure maybe 1013 millibar, the boiling temperature of water is 100 degrees Celsius. So, this boiling point changes as a function of saturation pressure. Therefore, at 23.37 millibar, the water boiling temperature will be around 20 degrees Celsius, and at 6.09 millibar, it will be around 0 degree Celsius. So, water can even evaporate at 0 degree Celsius if pressure is reduced to 6.09 millibar. So, to change from the liquid to vapor state, the latent heat of vaporization must be provided by the surrounding medium, so that the sensible heat of the product is reduced. So, the water vapor given off by the produced, however, must be properly removed to get efficient cooling. Here it is a cooling system can be shown in schematic diagram. So, in the vacuum cooling process, the pressure in the vacuum chamber is reduced from atmospheric to about 20 millibar, and during this time the evaporation is slow and relatively little cooling takes place. That is, temperature of the produce remains constant until saturation pressure at this temperature is reached. At approximately this pressure, the flash point occurs. This is the point where the water in the produce begins to vaporize and the produce begins to lose moisture and cool rapidly. So, this is the principle of the vacuum cooling. Okay. Cryogenic cooling, another very important, very good method keeping in view the quality of the products. This use of latent heat of vaporization of liquid nitrogen or solid carbon dioxide, that is popularly known as solid ice or dry ice, can produce boiling temperatures of maybe minus 196 degrees Celsius and minus 78 degrees Celsius respectively. And this is the basis of cryogenic cooling. In cryogenic cooling, the produce is cooled by conveying it through a tunnel in which the liquid nitrogen or solid carbon dioxide evaporates. However, at the above temperatures, the produce will freeze and thus be ruined as a fresh market product. So, this problem is prevented by careful control of the evaporation rate and the conveyor speed. So, that is very important because the temperature is very low here in the cryogenic cooling. So, proper care should be maintained, that is to make sure that there is a evaporation is proper, conveyor speed is proper. So, the freezing should be avoided, so that the freezing is avoided. Cryogenic cooling is relatively cheap to install, but it is expensive to run. Its main application is in the cooling of crops such as fruits, which have a seasonal production period and high value products. Evaporative cooling is an inexpensive and effective method of lowering produce temperature. It is most effective in the areas where humidity is low, and in this dry air is thrown moist paddy drawn through moist padding or a fine mist of water, then through the vented containers of the produce, as you can see here in this figure. As water changes from liquid to vapor, it absorbs the heat from the air and thereby lowers the produce temperature. The incoming air should be less than of about 65% relative humidity for effective evaporative cooling, and this method will only reduce the temperature by 5 to 8 degrees Celsius, etc. So, this method would be suitable for the warm season crops which require warmer storage, comparatively warmer storage temperatures like 7 to 12 degrees Celsius, and commodities such as tomatoes, peppers, cucumbers, eggplant, etc. Now, I think in this slide I have summarized, that is the comparison of various pre-cooling methods from the point of view of capital cost of the commonly used cooling system, or from the point of view of energy use of common energy use. So, the capital cost point of view, liquid ice cooling is the highest costly, vacuum cooling is comparatively less, and hydro cooling it involves least cost. From the energy use point of view, vacuum cooling uses maximum energy, followed by hydro cooling, followed by water spray vacuum, then packaging ice or forced air. So, here that is again like cooling time hours. If you see that ice cooling, it may take maybe 0.1 to 0.3 hours depending upon the load of the material etc. or 0.2 hydro cooling maybe 0.1 to 1 hour, vacuum cooling 0.3 to 2 hours, forced air cooling the same amount of material. If you are cooling by forced air, it may take around 1 to 10 hours, or even room temperature cooling it may take from 20 to 100 hours. So, it depends upon. Similarly, product moisture loss is almost very less in the ice cooling or hydro cooling, but in the vacuum cooling it is more moisture loss is there. In the forced air maybe 0.1 to 2%, room temperature cooling also there may be 0.1 to 2%. Then capital cost, I already told that all this except for that hydro cooling, forced air cooling and room cooling are low, vacuum cooling medium cost, medium capital is required, but ice cooling it needs a very high capital cost. Energy efficiency, that ice cooling, forced air cooling or room cooling, they are energy efficient processes, whereas that hydro cooling as well as vacuum cooling require high energy. So, this now I will summarize this lecture by saying that processing of fruits and vegetables involves major primary, secondary and tertiary operations. Primary operations involve sorting, grading, washing, ripening, blanching, size reduction etc. Secondary operations include preservation and product development methods. Tertiary operations include packaging of raw, cut and processed products and food or vegetables, and pre-cooling involves the cooling, room cooling, forced air cooling, ice cooling, hydro cooling, vacuum cooling, cryo cooling, evaporating cooling etc. and it is an important operation to reduce the field heat or sensible heat, to lower down this metabolic activity, so that the material is delivered to the processing plant or to the market in the desired state of quality and value. So, these are the references that have been used in this lecture. With this, thank you very much.